Hi, this is our quantitative data lecture. I know a lot of people, when they hear the word quantitative, their brain seems to shut down and there's a lot of anxiety. I'm going to not get too deeply into really quantitative stuff. We're really not studying statistics or simple regression, multiple regression. It's possible for you to do that if you'd like. I have some great lectures on the topics. But what we're really doing is we're really talking about data and data collection and analyzing the data when it comes in. And then we're talking about the different kinds of data that can be collected. So this really isn't a math or a statistics lecture. It's a quantitative data lecture. We used to have in the MSA program, MSA600, quantitative methods. So students actually were required to take a course and understand a little bit about statistics. But that course was eliminated. Some people believe that this class was supposed to replace that class, but that's not really true. This class is really designed to teach about research and thinking about problems and looking at literature and collecting data and solving the problem. So we're going to go through this. There's a lot of slides here, and I'm going to move rapidly through a lot of this. The reason is that you can print this and you can look at these slides. Keep in mind that on the final exam you'll see some questions from the lectures, and so you do need to listen to the lectures. So we're going to start out by talking about a type of research, type of quantitative research really. It's called descriptive research. And descriptive research is indeed a type of quantitative research, and it's probably the type of research that you're going to engage in at the graduate level, at the master's for sure. When you get to your PhD, you'll engage in a little bit more advanced research and maybe some directly quantitative methods research. But this is descriptive research, and we're going to understand what it's all about. What we try to do in descriptive research is understand the characteristics of an observed phenomenon. So we're really trying to say, for example, what's causing students not to complete their thesis in 16 weeks, or what's causing turnover in my organization. That's what we're trying to do. Is we're trying to say, look, I see this phenomenon, this thing that's happening, this piece of data, not completing 16 weeks. There's a certain number, 42%, or turnover, in the department is 12%. So we've got empirical observations of these phenomena, and then we're trying to really explore possible associations between two or more things, right? So what's causing students not to complete in 16 weeks? What's causing turnover in my organization or department? So that's what we're trying to do, and that's what descriptive research is very useful for. It examines the situation the way it is, and it seeks to shed light on it. So there's a number of ways to approach descriptive problems. One is an observation study, so this is a goal to quantify something that's happening. So one of the things you could do is, and I used to see this, I used to live in Baltimore, and I used to see people sometimes sit in lawn chairs and with a clipboard, and when the bus would go by that I was on, they would make notes on the clipboard. They were doing observation of the timetable of the bus and how well it was, where it's supposed to be on schedule, etc. So they were looking at the frequency of the buses, the schedule compliance with the buses, etc. So that was an observation study they were engaged in. There's also correlational research, which really talks about how one variable is influenced by other variables. In addition to correlation, you can do regression work in that area as well. And so we've got this number. When we get to +1, we say these two variables are exactly correlated. Whenever one changes, the other one changes exactly the same amount. Or if you get to -1, you say, well, when one goes up, the other one goes down exactly that number. But as you approach 0 on, whether plus or minus, the closer you get to 0, you get a scatter diagram, and you say these variables aren't related. And that's correlational research. Now, in an organizational setting, is it useful to say, I have found a correlation between compensation and turnover? The correlation is +4, plus 0.4. And what does that mean? And so there's a little bit of concern sometimes when we do correlational research that we're looking at things in sort of an abstract way and not really getting to the underlying causes. There's another type of descriptive research called developmental design. where we look at the changing phenomenon across various groups, which is called cross-sectional, males versus females, African Americans, European Americans, Hispanic Americans, looking across groups. Or we're looking over time, how did this one group's behavior change over 4 decades, 40 years, longitudinal. And then, of course, the one that you're most likely to be using and encounter is survey research, where we acquire information, and it's perceptional information, right, if you're giving out a survey, to understand the characteristics, the opinions, the attitudes, or the experiences. And the goal is to learn about a large population, as large population as you need to study, by using a sample, which is a manageable number of participants. So, and there's 2 types of survey research. This is the research that's probably, again, going to be most relevant to you. There's interviews, which are structured or semi-structured, face-to-face, telephone, video conference, and they have a high response rate because you call up and say, well, can I interview you? And they say yes or no, right? So you keep calling until you get enough interviews. Or a questionnaire, and about questionnaires, there's possibilities if the questionnaire is not done well to have a low return rate, and people need to have assurances that what they say on a questionnaire is going to be anonymous, not attributed to them, because they don't want to get themselves in trouble. So anyway, that's a key aspect of descriptive research are those methods. And we're going to focus on survey and interview here very quickly. Again, I've provided you with some resources, including your textbook and another resource that talks about great survey design methods. So I'm going to kind of skim through this fairly fast, because a lot of you in your work this semester, you're going to be designing surveys, right? So designing surveys is collecting primary data. Surveys are descriptive research. Their objective of the questions is to describe what's happening and why it's happening. And so in the surveys, we collect multiple kinds of data. One is demographic data. And the reason we collect demographic data about the respondent is because we might want to analyze the responses across certain demographics, like males versus females, or older versus younger, or some ethnicity versus another ethnicity. And so that's why you collect demographic data. You've heard me say before, and I'll say it again, if you're not going to use the demographic data for your work, don't collect it. Don't waste people's time. Don't make them suspicious of what you're up to, right? And another objective of what we're trying to do here is really accomplish our research objective to understand what's causing turnover, how do workers feel about shifting to a 4-day work week? Are they pro or con, and why? And what are their views? The benefits of survey research: quick, inexpensive, efficient, accurate means of assessing data about the population. So a lot of good stuff there. Okay, so survey design, again, I'm going to blow through this now. What should be asked? How should each question be phrased? Best thing to do is get an example like I provide in the proposal template and use it, right? In what sequence should the questions be arranged? Should the questionnaire be pre-tested? Yeah, give it to some people a small group, friends, family, people at work, the person sits at the desk next to you. Because that way you can see, if you ask a question that doesn't make sense to somebody, they can point that out to you. What do you ask about? You ask about things that are relative to your research sub-questions, right? And that's why I asked you in week 6 of the semester to fill out a form, a data collection form that causes you to have to think through, here's my research sub-question, what data do I need on my survey to answer that? And so that's why you do that, right? And also, we like to keep our questions short because we don't really want to discourage people from taking it. So you can sort of see different ways to structure questions. Yes, no. I've had students, every question was yes, no, and that's not a good way to do it. It's not quantitative when you have yes or no. That's binary. It's 1 or 0, right? But if you give them a scale 1 to 5, you can do some interesting things. And as you move down this, you can see categorical variables, which section did you sit in, first class, business, or coach. You can see frequencies, but then you get to the numerical things that we can actually apply descriptive statistics to. We can look at the average score, standard deviation of the scores across all the respondents for a particular question. So that's called a Likert scale, 1, 2, 3, 4, 5. Even if we say never, rarely, sometimes, often, very often, it's still 1 to 5 scale. right? And then the other thing about questions is always having open-ended questions. And I'll discuss this week and next week how to deal with open-ended questions when they come back to you. What are you going to do with them, right? There's a lot of discussion about how to sequence questions on a survey, but we're not going to get too hung up about that. If when I review your surveys that you submit to me in your draft versions, if I think that sequencing or other aspects of how you put those questions together needs work, I'll let you know. So layout of questionnaire should be neat and attractive. That's why I say to people, don't just write some questions and at the top say answer the following questions 1 to 5. Use something that's nice and attractive and easy to use. Use the example from the proposal template and then just put your questions into that format. So it should be neat and attractive. The instructions at the top should be easy to follow. Shouldn't be too long because people will get, if they see a 37-question survey, they won't do it. And the responses should be structured and also some open-ended questions as well. Rather than ask for age, provide age categories. A single age doesn't help you a lot. You need categorical variables for age. Pre-test and revise. Have someone take the test, see what they think about it. Now, we always talk about validity and reliability, and that's really kind of an important thing. There's a long process and a detailed process to take an instrument, a data collection instrument, and see if it's valid and see if it's reliable. Valid means it's actually measuring what I wanted to measure, and reliable means that I get the same consistent answers from a person over and over and over again. So this validity and reliability is really kind of important stuff, and there's statistical processes for taking a survey and testing it for validity and reliability. Thing is, you're not going to have time to do that in your graduate program. So in most cases, your surveys that you make up for your work are not going to have been tested for validity and reliability. You can't say they're not valid or reliable. You don't know that. You haven't tested it, right? So you basically are always going to say not tested for validity and reliability, designed for the sole purpose of this research, but not yet tested. So that's kind of important stuff, right? And I'm just going to move on. This is just more detail about validity and reliability. In terms of procedures for surveys, we really have two big piles of stuff here, right? One pile is the whole population, and the target population is all the people that could answer a survey. Let's think about that. If I'm trying to find out why students aren't completing the capstone in 16 weeks, well, who's my target population? It's everybody who's ever taken the capstone. And then you have to make some decisions, right? Is it both those who didn't complete the course in 16 weeks and those who did? Because maybe you want to know from those who did what they think about the ones who didn't. Maybe you want their opinions. Is it the instructors who teach the class as well? Because maybe they have some insight as to why some do and some don't. So what is the target population? How big is that? And then, if you're looking back over 16 years and you're looking at 20 classes per year, 20 students, 400 per year, 5,000 students, right? It's too big. It's just too large. So you're going to figure out maybe 200 is the right number, and we'll talk about that. And then you want to try to reach those 200. And so that's called sampling, right? So what approach do we use to sample from the population? Well, sampling involves procedures for using a small number. Now, here's what's really important about research. In order for your research to be reliable and accurate and useful to people, the sample has to look like or be representative of the target population. It has to include males and females, military, non-military, students who took the class face-to-face, students who took the class online, etc. Right? So this idea of sampling is very important, and it does take some thought to get your sample worked out so that it is truly representative of your target population. One of the best ways you can draw a sample from the whole population is to take all 5,000 names and draw them from a hat, completely, totally random, right? And then, that's the best way. So how you do this, you define your target population, then you figure out how you're going to sample this. Are you just going to do a simple random sample, 5,000 in a hat, pull out 200 names, right? And then go find their email addresses from MSA department. Or you're going to do a systematic sample. Out of the 5,000, you want 200, so you divide 200 into 5,000, and maybe that's every 50th name. That's another way to do it. Stratified. Maybe you want to have ensure that there's males, so you pull out all the males into a pile, and some females, and you put them in another pile. From the males and females, you want some military and some non-military, so that's called stratification. So in other words, you take your total population, you take the names and put them into buckets. You're stratifying. And then from each bucket, you pull some percentage, 50 from this bucket, 50 from that bucket. Convenience introduces error because it was easy. I grabbed the people that went to Detroit because I'm close to Detroit. Now, Detroit's not representative of all the other locations that we have. But it was convenient for you, so that introduces a little bit of error into your work, and you have to disclose that. Judgmental sample, well, I think I'm going to pick on the people from this place and that place, and the people who did this and the people who did that. So those are different sampling methods. So what's a good sample size? Key issue is sample must be representative of population, as I said, otherwise you have error. Basic rule is the larger the sample, the better. If you can do the whole group, excellent. Like if you have 50 people in your department, can you do all 50? That would be great. Or you can take a sample. How big does that sample need to be? So for smaller populations where you have 100 or fewer, you try to survey the entire population. If the population is around 500, you try to sample 50%. If it's around 1,500, you sample 20%. And you can sort of see as you get larger, law of large numbers kicks in, the sample size kind of flattens out. And so over 5,000, if you get 400, you probably are going to have a reasonable sample as long as the sample is selected in a fairly random fashion or stratified random fashion. So there's also a mathematical formula, which we're not going to worry about too much to figure out your sample size. If your sample is too small, that's a problem. But otherwise, as long as your sample is fairly large, significantly large, intuitively large, then you're going to be okay. Sampling bias, I already mentioned. You can have all kinds of bias in your sample. You could have pick the people to participate. I always believe in a lot of these recent elections we've had, the polls come out and they tell us a certain thing's going to happen. It doesn't happen, and I always believe that's because they go to the big cities, they go to people that, favor certain parties, and just lots of bias in the sampling for a lot of these political surveys. So I don't believe any political surveys. When they come up and say this candidate's going to win by a landslide, you can't believe it. Anyway, survey process, you determine your population sample, you determine your distribution method, how the survey is going to reach the sample, people, respondents, how it's going to be returned. You look at the survey itself and the instructions, you conduct a survey, and so on, right? It's fairly straightforward. So in terms of writing about your survey methods, you have to be as detailed as possible. I always say, if your 16-year-old daughter came to you and said she was going to spend the summer in Paris, how much detail would you want about her plans, right? You'd want a lot. And I'm the same way. When you tell me you're going to write a methodology, a plan to collect your data, I want as much detail as you can give me. So what are the characteristics of the subject? What's the population? What's the sample? How'd you come up with the sample? Is the survey anonymous? How are you going to send them out? How are you going to get them back, etc.? We'll continue on. I have more comments about those things later. Not later, maybe later in this lecture, but certainly later in the next 2 lectures. Interview techniques. Interviews are great. I always say you should do a survey and then a couple interviews. Give a survey out to the employees and then interview the director of HR or somebody, because interviews really give you a chance to check what happened on the survey. And it's called field work, right? You select your interviewees. You have a rationale for why you pick these people. You prep specific questions. You have to have a questionnaire for interviews, right? Because you want to ask everybody you interview the exact same questions, or else you can't use the results. It's very hard to do. And I always say for interviews, you want to have 1 to 5 questions, just like on the survey. So you say to the director of HR on a scale 1 to 5, how serious do you think turnover is in the organization? She or he says, well, it's a 4. And then you say, well, explain your answer. And they talk to you, and then you can go back and forth. And you say, well, why do you feel that way and stuff? So I'm a big fan of having empirical data, quantitative data on interview questions, interview surveys. Make sure your interviews are not too long because people won't want to spend more than 15, 20 minutes. This says less than 10, but you can get 20 minutes out of a person, usually fairly easy. If you go over a half hour, they start to not want to work with you anymore. You need consent. If you're calling them on the phone, you say, do you agree to participate? They say yes, that's consent. If you're face-to-face, you hand them a form, let them read about what the protections are, and then sign the form, and you keep the form. You record your responses, you keep your reactions and your thoughts to yourself. Don't raise eyebrows. This is not a social visit. This is a business and data collection visit, and you have to remain unbiased and impartial. Anonymity, people may be concerned about that, so just promise them you'll strip off any identifying information. And remember also that when you ask people to remember something, that memory is hugely fallible. Okay, experimental studies are done more in science, more at the PhD level. We can use them to test for cause and effect relationships, but you see this more in science, where we want to look and see how someone reacts to a certain drug or pharmaceutical and so on. Now, with your experimental studies, we tend to get a little bit more quantitative and a little bit more math-oriented, right? So we have variables, right? The person's temperature, the person's heart rate. We administer a drug, and we watch what happens to their heart rate or their temperature or whatever. So these are called variables, right? And so whatever we're studying, like I want to see what the impact on a person's blood pressure is of these 5 different medicines. Blood pressure is the main thing, right? So that's your dependent variable. So then you apply medicine A, that's your independent variable A, and see what happens to the blood pressure. And then you apply B and C and D and E, and those are your independent variables, right? So if you wanted to know what factors are causing turnover in the organization to increase, the main thing is turnover, right? So that's your dependent variable. And you've come up with some different ideas. You think it could be either compensation or workload or poor supervision, working hours or working conditions. You have to get out in the muck or lift trash cans or whatever. And so you have 5 independent variables, and you want to see how each one influences turnover. So can we do that with surveys? Sure. We can, on a survey question, we can say, to what extent on a scale of 1 to 5 do you think low compensation in this organization causes turnover? So they're going to get some answers, right? So you've got your relationship. Another question about workload. You get your 1 to 5 scores. So you can do the same thing with surveys. We're trying to stay away from that highly empirical stuff here. How do we analyze quantitative data? Well, we use statistics most likely, right? Data comes in, you get your surveys back, and you take all the responses to question 1, put them in a spreadsheet, all the responses to question 2, and so on. You put them in a spreadsheet. So once you do that, then you're really ready to do a little bit of analysis, right? Now remember that as you get all of your responses, you really need to put them in graphs and charts and stuff. And we use Excel usually to do that, or some sort of a spreadsheet or other graphical tool maker, right? Now recognize that statistics, which really shouldn't terrorize you, even though it usually does, has 2 basic levels of functionality, right? One thing is called descriptive statistics, and at the master's level, that's probably what you all are going to use for your quantitative approach, right? You're going to take question number 1, and you're going to have a whole bunch of people who had either a 1 or 2 or 3 or 4 or 5, and you're going to say the average score across all these people was blank. You're also going to say standard deviation was blank, and I'll tell you why later. I'll explain why that's important, the standard deviation, because if you just say the mean score was 3, well, you don't know if everybody was a 1, half were a 1 and half were a 5, or if everybody was in the middle. And there's a big difference. Standard deviation kind of lets the reader know that the mean was 3, but standard deviation was this number, and does that mean everybody was in the middle, or we had people bimodal at either end? So it's kind of important. So they're very useful, descriptive statistics. The other kind of statistics are a little more advanced, and I have some great lectures on regression. People from all around the world subscribe to my lectures, but you probably don't want to listen to those this semester. You probably have other things going on in your lives, so other than listen to 4 fairly lengthy regression analysis lectures. So, but those are called inferential statistics, and those are the ones where we can take variable A and as I said, dependent variable A, and then see what these other variables are doing to it as they change. We get into scales, and again, this is not a math course, but this is important to know when you're doing your work with statistics. Some of our variables I mentioned earlier were categorical variables, like your gender or your male MF, right? Race, color, city, all those things. Those are categorical variables, they're not numeric variables. The other variables are all numeric, and so with numeric variables, ordinal interval ratio, we can use different tools, but with nominal we have to, we're a little bit constrained. We have to sort of like convert male-female thing to numbers, ones and zeros and stuff, and then do stuff to it. So knowing that data is nominal or categorical is really important. The other ones are less important, but that difference between nominal or ordinal interval ratio is kind of an important thing. It lets you know which tools you can and can't use. We already talked about mode, median, and mean. I'm not going to go through those, but most of you have been around long enough. You've gotten through your bachelor's degree, so you know what the mean score is of something, right? And so again, if I look at this and I look at this curve at the bottom here, and I try to figure out what's the mean score. And generally we have data comes in that's normally distributed, like you have the average in the middle, right? And then you have your strangies on the right-hand side and your strangies on the left-hand side. And your standard deviation tells you how far away from the sort of normal your strange ones are, your plus strange and your negative strange, your unusual characteristics, right? So this is important to know, but I'm not going to spend a lot of time talking about it. But this standard deviation thing is important to know, because if your scores are all have a mean of 3 on your 1 to 5, but you have a very low standard deviation, that tells a person they're all about in the middle. If, on the other hand, your average or your mean is 3, but your standard deviation is plus or minus 3, that gives you a whole different message about how your data was skewed. So a little bit of stuff. Also, sometimes our data is skewed. I could give you lots of good examples about the skewing data or bimodal data and stuff, but we're not going to get into that. So, so I used to tell students, especially when I was in the classroom and had some chalk on my hands, what kind of test do you want to do? I said, don't be afraid. Most master's level students are going to use descriptive statistics. You're going to use Likert scale. After the data is collected, you can look at the frequency, the mean, the standard deviation for all the responses. So you can see down here, question 1, to what extent do you feel that communication problems are causing turnover? And I made up some data here, right? Nobody said 1. You had 9, 6, 10, and 1, 26 people. Mean score of 3.25 with a standard deviation of 1.53. So that tells me that the data is fairly clustered in the middle. So kind of like everybody feels fairly common about that, and that matches what the data says in the answers. There's other tests too. A lot of times I want to see, are males or females more likely to have anxiety before a test, right? That would be an analysis of difference between groups. Older people, younger people, or middle-aged people. Analyzing salary differences, males and females. So those are you use those tests I was showing you, either a t-test or analysis of variance, depending on whether you want to look at these things. But then, a lot of times we really don't want to compare differences like male-female. We want to compare or analyze two different variables. Like I always say to you, it's kind of sad that the school system did to you what they did to you. If you're afraid of statistics or math, right? Some of you are whizzes at this stuff, but some of you are afraid of it, terrorized by it, right? I always say, well, it's kind of sad. If you had a 10-year-old, you should be teaching the 10-year-old to see if there's a correlation between their grades in school and their allowance. They should be able to correlate that, mathematically. And it's hugely important that a 10-year-old get over that fear. It's like being afraid of swimming, right? You got to get over it, and you got to get over it at a young age. And you, the parents, should be making that happen. Anyway, so, we don't do that in school. We don't do it at home. And so children grow up being terrified of math and then majoring in HR because there's no math in HR or whatever. And I have a lot of respect for my HR people, but sometimes people were in HR because they really didn't like the math courses, right? Anyway, so correlation and regression are tools that we use there. So, and all this, of course, I go through in my lectures, my 4 lectures on regression analysis, which take and make it really simple on how to use basic statistical tools to understand data. Okay, and then hypotheses. I already said to you we're not going to do hypotheses tests, because if you go running into your boss and you say to your boss, hey, I have proven that there's a correlation between wages and turnover. Right? I proved my hypothesis. The boss is going to look at you and say, well, it's intuitive anyway. I knew that already. Why are you wasting my time? Right? So we're not going to be using that. Anyway, methodological limitations, I've already mentioned. Your sample is too small. That's a problem. You need to disclose that. If you only have 5 people out of 50, it's too few. It's not representative. Survey hasn't been tested for validity and reliability because you made it up, right? That's something you need to disclose. Sample's not representative. It's too small. It's a convenient sample. It's just not random, right? And then, it's really useful to use a statistical package tool to run statistics. We're not going to get into that, but I teach a couple classes. I teach statistics, and I teach a class called Analytical Methods. And I require, those are both required classes in another program. And I require that students use the statistical package, which is called Stat Tools. It comes with your textbook. And it's really easy to use, and you can do just pretty amazing stuff with it. And then you analyze the data. And then as you analyze the data, you create your charts and your tables. You can just do that with basic Excel. Then you, in your chapter 4, which we'll talk about later, you're going to put these charts and tables. And then you're going to describe the charts and tables in paragraphs. And then you have to actually analyze the data. Just writing it in words like three people said number 1, 7 people said number 2, right? It's just writing words about the charts, right? But you really got to say, so what? So what? Why did everyone score the question a 5? Or most people scored a 5 or a 3 or a 2. And why? How do you explain the spread of those responses in that question? And that's called analysis, right? So that's kind of key. And very often students just don't do that. They don't do the analysis. So presenting, I wanted to switch subjects now. That's your statistics stuff. Some of you may do something that's more financially oriented, like should we shift from having our own data center to cloud computing or something, or I want to start up a dog kennel or whatever. And so if you do that, you're going to be looking at financial data. Now, financial data is different. It's different than statistical data. It consists, and you learn this in MSA600, it consists down the left-hand side of expenses, capital, which are one-time, large, and operating, which happen all the time, monthly, annually, quarterly. And then it has income at the bottom, and then it has years across the top. And so this is what we call a feasibility table. And you have to have the feasibility table if you're going to do financial analysis. There's no getting around it. And then once you get your net income, you can sort of look across the table and do a little computation to figure out when your organization is going to break even for whatever you're trying to analyze. So break-even analysis is really important because it determines the number of units that have to be engaged in order to recoup all the costs that have been put into the enterprise. And so you break even, let's just say you put $100,000 up front for a building, and then you're spending $10,000 a month, right? So the first month you need to get $110,000. You're not going to make $110,000 the first month. Next month, $120,000 because you spend $10,000 more in addition to the original $100,000. So maybe if you add up the revenue from the first month and the second month, you're getting close to $120,000. Probably not. You're probably not going to approach getting your money back until somewhere around like year 2 or year 3. And that's what this is all about. And so you recognize that at your break-even point, you've recouped all of your capital expenses, your upfront expenses, plus your ongoing operating expenses, and you've really gotten to zero. And then after that, you can really be profitable. Recognize also that if you're doing financial analysis, you've got multiple costs. You've got fixed costs that you have to spend every month. That's like paying your employees' salaries, assuming you don't change the number of employees. And then you got variable costs. If you make more shoes, you need more rubber and more cotton and more string or whatever your variable costs are. Your things that go into your product for a total cost, right? So your total revenue minus your total cost equals your profit. And so here's a formula for calculating break-even point. You study this in MSA 601. I'm not going to spend a lot of time on this, but these are things you have to do if you decide you want to do a business plan, feasibility study, or whatever. Okay, so that's what it looks like. This was an example that I've used, but I've been going on for 35 minutes, so I'm going to just kind of wind this down. And I hope that you weren't too intimidated by looking and discussing quantitative methods. Okay, this discussion parallels your chapter in your text. I've used slides from the text as part of this lecture and the next lecture, really. So I hope this has been useful to you. I'll ask you a few questions about quantitative methods, descriptive statistics on the final quiz. Anyway, that's it for here. Your next lecture is much shorter. I believe it's 11 or 12 PowerPoints. It's on qualitative data, and it's really three chapters from the book, but we're really going to just focus on the qualitative dimensions of data collection, which is very different than quantitative. And quantitative is the more relevant to what you're trying to do, probably, in writing your research proposal and ultimately conducting your actual research.